Okay, so for number one, sketch the functions. So first we have to determine end behavior. Since it's a positive function, that means the right side goes up. And because it's an odd function, that means the left side goes in the different direction, which is down. And B, what is the y-intercept? The y-intercept is what happens when you plug 0 into x. So when you plug 0 into this, you get 0. Plug 0 into that, you get 0. 2 times 0 is 0, plus 1. The y-intercept is 0, comma 1. So you put 0, 1 right here. And end behavior says it has to go up and then down. So it probably does something like this. Okay, it just said sketch it with the general shape. It didn't say to find intercepts, so don't worry about finding the intercepts. The main thing I want you just to worry about is the end behavior and the y-intercept. So end behavior, this is negative, so that means the right side goes down, and since it's an even degree function, that means the left side has to go in the same direction. The y-intercept, if you plug 0 into everything, that's 0, 0, 0, 0, negative 8. So the y-intercept is 0, negative 8. So somewhere down here. So we know it has to go down, down, up, through the y-intercept, up again, and back down. Number 3, positive, so the right side goes up. Even function, that means the left side goes up as well. And the y-intercept, if we plug 0 into everything, 0, 0, 0, 0, the y-intercept is 0, comma 0. It's right there. And it probably looks something like this. Number 4, negative functions, that means the right side goes down. Since it's an odd degree, that means they go in opposite directions, so the left side has to go up. The y-intercept, you plug 0 into x, you get 0, negative 11. So there's 0, negative 11 there. And it comes probably down, back up, and down. For this one, our intercepts, so we can actually use intercepts now. Our intercepts would be positive 3, negative 2, multiplicity 2 because of the squared, and then 5. So our intercepts are at negative 2, 3, and 5. You didn't have to do this, it just says to sketch it. So this function right here, this x has a degree of 1. This x has a degree of 2. This has a degree of 1. So this is a degree 4 function. It's positive, that means the right side goes up. And since it's a degree 4, 1 plus 2 is 3, 3 plus 1 is 4, the left side has to go in the same direction. So it goes up, up. And just make sure we hit all the points. It said negative 2 had multiplicity, so that means it should bounce off of negative 2, and you would finish with your graph. And for number 6, our intercepts would be 6 and negative 2 multiplicity 3. It looks like it's positive, but look, this is a positive 1/3. This leading coefficient's a negative 1. This leading coefficient's a positive 1. So overall, this function has a negative end behavior. So the right side's going to go down. This is degree 3. This is degree 1. 3 plus 1 is 4. That's an even function, so they have to go in the same direction. So we've got negative 2 and 6. So it might look something like this. Looking back at 5 and 6, how many roots does 5 have? So there is 1, 2, 3 roots. How many x-intercepts does it have? 1, 2, 3 x-intercepts. How many roots does number 6 have? There's 1, 2. And same thing, there's only 2 x-intercepts. For number 9, write it in factored form. So this first one, since there's 4 and 20, I know there's a GCF there, 9 and 5. You look for things that have a GCF, that kind of tells you whether to do factoring or not. So I'm going to group these guys together and then group these guys together. So if I factor out a 4x squared, when you factor out 4x squared from here, you're just left with an x. 20x squared divided by 4x squared is just plus 5. Over here, if I factor out a negative 9, I'm going to be left with an x. Or sorry, if I factor out a 9, let's see here. Yeah, factor out a negative 9. And then negative 45 divided by negative 9 is a positive 5. And they both share x plus 5 in common. So that means you would write x plus 5 down. And what's left over here would be a 4x squared minus 9. However, since this is a difference of 2 squares, 4 is a square number and 9 is a square number, that could be factored even further. So the square root of 4x squared is 2x. The square root of 9 is 3. And since it's a difference of 2 squares, they have to be different signs. Okay. It says find all the roots. So for all the roots, we're going to have a root of negative 5. This would be, I might want to slow down and show you guys how to get the roots. So you'd set each of these guys equal to 0. If you set them equal to 0, that's how you would find the roots. So we would have x plus 5 equals 0, 2x plus 3 equals 0, and 2x minus 3 equals 0. So when you subtract 5 from both sides, you get x equals negative 5. That's your first root. Subtract 3 from both sides, you get 2x equals negative 3. Divide both sides by 2, x equals negative 3 halves. That's another root. And then you add 3 to both sides. 2x equals 3. Divide both sides by 2. X equals 3 halves. So to keep the video a little bit shorter, because I don't have a lot of space, I'm pretty much going to be skipping the set equal to 0 step, and I'm just going to give the intercepts. If you have questions, please email me. So that's part B. Those are all of our intercepts. And part C, how many intercepts does the function have? 3. 1, 2, 3 intercepts. Okay. For number 10, I should start doing these on a separate sheet of paper. X to the 5th minus 50x cubed plus 49x. So first thing that you want to do is take out the GCF. They all share an x in common. You're left with x to the 4th minus 50x squared plus 49. And then when I factor this, doing my guess and check, I need two things that multiply to be x to the 4th power. That would be x squared and x squared. I need two things that multiply to positive 49 but add to negative 50. And that would be minus 49 and minus 1. But 49 is a perfect square number, so for the difference of two squares, I could factor this guy. Two things that multiply to x squared are x and x. Two things that multiply to 49 are 7 and 7. One's positive, one's negative. And the second one over here is also a difference of two squares problem. The square root of x squared is x. Square root of 1 is 1. Positive, negative. So this is part A. factored completely. Part B says what are the intercepts. So if you have x equals 0, I said I wouldn't do this, but I'm going to do it one more time. X plus 7 equals 0, x minus 7 equals 0, x plus 1 equals 0, x minus 1 equals 0. You set them all equal to 0 to find the zeros of the function. And you get 0, negative 7, positive 7, negative 1, positive 1. That's what you would get if you were to solve each of them. So this would be your answer for B, 5 answers. And for C, how many intercepts? There's 5. Number 11. X to the third minus 4x squared minus 12. X. Take out the GCF first. They all have an x in them. X squared minus 4x minus 12. And then you would factor this guy, x and x, because x times x is x squared. Two numbers that multiply to negative 12 but add to negative 4. That would be negative 6, positive 2. So this is your problem in factored form. So your factors are going to be for part B, that's the answer for A. Part B, you're going to have 0, positive 6, negative 2. And your last part, there are 3 intercepts. For number 12, problem said find all the roots if x minus 7 is a factor. So you have x cubed minus 12x squared plus 41x minus 42. And it said that x minus 7 was a factor. So I'm going to use synthetic division. Synthetic division, you take the 0 of this guy right here, that's a positive 7. Because 7 minus 7 is 0, so your x value is 7. And underneath this, I'm going to put all of the coefficients. This has a coefficient of 1, negative 12, positive 41, negative 42. You bring the first one down. Multiply. 7 times 1 is 7. And negative 12 plus 7 is negative 5. Multiply 7 times negative 5, that's negative 35. Combine those, 41 minus 35 is 6. 7 times 6 is 42, and those cancel to give you 0. So, since our leading coefficient was x cubed before we divided, the leading coefficient here is going to be an x squared. So this is x squared minus 5x plus 6. You just start with a degree 1 lower than the original problem, and then subtract 1 from the exponents until you get your final factor. But this could also be factored as well. Two numbers that multiply to 6 and add to negative 5 would be negative 2 and negative 3. So our final answer for part A, the factored form, is x minus 2, x minus 3, and also the x minus 7 from the beginning of the problem, because it said x minus 7 was a factor. That's A. Part B, your answers are 2, 3, and 7. That means that there are 3 intercepts. For number 13. Number 13 says we got 2x cubed plus 3x squared minus 89x plus 120. And it says if one of the roots is 5. That doesn't mean you take the opposite of it. This means that x minus 5 is one of your factors. It just so happens 5 is the 0. So 5 goes out. Each of the coefficients come down. 2, 3, negative 89, 120. First coefficient comes down. 5 times 2 is 10. 3 plus 10 is 13. 5 times 13 is 65. Negative 89 plus 65 is negative 24. 5 times negative 24 is negative 120, and that's 0. So that means that this factors to x minus 5. And remember, your leading degree is going to be 1 less than the original problem. So this would be a 2x squared plus 13x minus 24. However, you can factor this. Two things that multiply to be 2x squared are 2x and x. Two numbers that multiply to negative 24, okay, but after we check everything, we have to have a positive 13. Okay. So the factors of 24 are 1 and 24, 2 and 12, 3 and 8, 4 and 6. Since this is an odd number, I know I'm going to need an odd number from here, and that would be this guy. I know 8 cannot go with the 2x because 2 and 8 have a GCF of 2. So 8 would go over here and 3 would go over here. Let's check to make sure it's right. You can always check. Even if you guys use one of the other numbers, you can always check and go back and fix it if it's wrong. 3 times x is 3x. 2x times 8 is 16x. Since I wanted this to be a positive 13, that means I would need 16x minus 3x. That forces the negative 3, or the 3 to be negative, and the 8 to be positive. So for part A, this is my factored form. Part B, your answers are positive 5. We would do 3 over 2 and negative 8, meaning that there are 3 intercepts. For 14, x to the 4th plus 9x squared minus 36. So if we factor this, two things that multiply to be x to the 4th are x squared. Two things that multiply to negative 36 but add to a positive 9, that would be a positive 12 and a negative 3. Because 12 times x squared is 12x squared. 3 times x squared is negative 3x squared, and they combine to be positive 9. So that's correct. And these guys can't be factored anymore. So this would be your answer for part A. For part B, you have to set these equal to 0. So I'm going to slow down a little bit, go back to how you're supposed to do it. You take the first factor, x squared plus 12 equals 0. Take the second factor, x squared minus 3 equals 0. And we solve. So subtract 12 from both sides. We're doing PEMDAS backwards. So x squared equals negative 12. And then if we square root both sides, the square root of 12 breaks down into 2 times 6, or 2 times 3. So we have one pair of 2's. The 2 comes outside the root. Since we're taking the square root of a negative number, we need to bring out I, which is the square root of negative 1. And then since 3 is left all by itself, it goes back under the root. So x is plus or minus 2i root 3. Over here, we add 3 to both sides. So we have x squared equals positive 3. Square root both sides. X is plus or minus root 3. Okay. So these guys, if it has an I, would be your imaginary roots. These would be your real roots. There's two of them here. There's positive root 3, negative root 3. There's two imaginary roots. There's a positive 2i root 3 and a negative 2i root 3. So for part B, when it asks you what are the roots, I believe. Part B asks you, find all the roots, real and imaginary, with their multiplicity. So these are all the roots. We've got 2i root 3, negative 2i root 3, root 3, negative root 3. Those are all the roots for part B. And for part C, it says how many x-intercepts do you have? So imaginary roots do not count as x-intercepts, okay? Because they're saying it's imaginary that they cross the x-axis. So therefore, you only have two x-intercepts, which would be those two guys, root 3 and negative root 3. 15. X cubed plus 7x squared plus 34x plus 66, with x plus 3 being a factor. Synthetic division. The opposite of positive 3 is negative 3. That's our root. You plug negative 3 in to get 0. The coefficients are 1, 7, 34, and 66. Bring the first one down. Negative 3 times 1 is negative 3. 7 minus 3 is 4. Negative 3 times 4 is negative 12. 34 minus 12 is 22. Negative 3 times 22 is negative 66. And the leading factor, or the leading degree, should be 1 less than the original problem. So this is x squared plus 4x plus 22. So in factored form, part A, we get x plus 3, because that's a factor, and x squared plus 4x plus 22 is the other factor. Okay, so for B, with my x-intercepts, the first one is just going to be negative 3. But for this guy, I got to use the quadratic formula. And for those of you who don't remember, quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Thank you, thank you. So, negative b, negative 4, plus or minus the square root of b squared, 4 squared, minus 4 times a, which is 1, times c, which is 22. So that's negative 4 plus or minus the square root of 16 minus 88. And that's negative 4 plus or minus the square root of negative 72. Which means we're going to have an imaginary root. So this breaks up into 2 and 36, and that breaks up into 6 and 6. You could stop right there, and you would get negative 4 plus or minus 6, because it's a negative, you have to have an I come out, root 2. If you decided to keep factoring this guy out, you went from 6, you went to 3 and 2. From that is 2 and 3. You'd pull a set of 2's out. You'd pull a set of 3's out. 2 times 3 is 6, with a 2 left over in the root. So whenever you have a copy, you can kind of just stop there without making the branches keep going. So this is our imaginary root. So our answer to B is negative 3 and negative 4 plus or minus 6i root 2. So for C, we don't count imaginary numbers as our x-intercepts because they don't exist on the x-axis, so there is only one x-intercept. And 16. It says 3x to the fourth minus 16x cubed plus 3x squared plus 46x plus 24. And it says if the zeros are -1 and 4. What that means is they're giving you two factors already. You have x plus 1 and x minus 4 factors. You're going to take these factors and you're going to use division to come up with your final answer. So I'm going to use synthetic division, -1, bring in 3, -16, 3, 46, 24. Bring down the 3 first. -1 times 3 is -3. Those combine to be -19. -1 times -19 is +19. Those combine to 22. -1 times 22 is -22. 46 minus 22 is 24. -1 times 24 is -24. Those combine to be 0. But it also said that 4 was a factor. So we're going to take these numbers and divide using those guys as coefficients. So bring down the first one. 4 times 3 is 12. -19 plus 12 is -7. 4 times -7 is -28. Those combine to make -6. 4 times -6 is -24. Those combine to be 0. So since we divided twice, we're going to go 2 less than the leading degree. So our final answer for part A, the factored form, is x plus 1, x minus 4, and 3x squared minus 7x minus 6. However, this part can be factored. So two numbers that multiply to be 3x squared are 3x and x. The factors of 6 are 1 and 6 and 3 and 2. So I'm going to try the 3 and the 2. 2 times x is 2x. 3x times 3 is 9x. Since I want this to be a -7, that means the negative has to go on the 9. So this would be a -3, +2. So this is my completely factored form for A. If you use the different numbers or you put them in the wrong spot, check it, see that it doesn't work, go back and fix it. It's called guess and check for a reason. There's also that one method that I shouldn't tell you how to do, but you can find it on YouTube. It's called bottoms up. Okay. B, how many intercepts are there? Or what are the intercepts, the roots? -1, 4, that would be -2/3, and +3. And there are a total of 4 intercepts. For 17, we can bring this 2 in front because these are all being multiplied together. So this would be 2x, x plus 3, 2 minus x. So if you look at the leading coefficients, that's positive, positive, negative. Positive times a positive is positive, but a positive times a negative is negative. So the right side is going to be going down. And there's x to the first, another x to the first, x to the first. So this is a third degree function. The left side has to go in an opposite direction. And my roots are at 0, -3, +2. 0, -3, +2. Our y-intercepts, by plugging in 0 to everything, we'd have 0, times 3 times 2 times 2. Anything times 0 is 0, so our y-intercept is 0, 0. So right side goes down, left side is up, and we go through all the points. For 18, factor first. X in the front, x squared minus 2x minus 2. That can't be factored. Or can it? Oh, that's not minus 2x, that's minus x. What am I thinking? Minus x. That can be factored. So when you finish factoring it, you need two numbers that multiply to negative 2 but add to negative 1. It's negative 2 and 1. So our factors are 0, 2, negative 1. 0, 2, negative 1. Our y-intercept, by plugging in 0 to everything, we got 0, 0, and 0. So our y-intercept is 0, 0. It's positive in front, so the right side goes up. Odd function means the left side goes in the opposite direction. So it comes up, goes through the points, finishes that way. Okay. By the way, it says label your x-intercepts. These are your x-intercepts. X-intercepts. I'm doing a bad job of labeling, but it's my weekend. Kind of want to go home. Actually, okay, we're good. Paige hasn't called yet to pick her up. We got time. So finish factoring. This first one, when you finish factoring, two things that multiply to negative 4 but add to negative 3. That's negative 4 and positive 1. X minus 4. So you can combine this to be x minus 4 squared times x plus 1. So your intercepts are 4 mult 2, multiplicity 2, and negative 1. So negative 1, 1, 2, 3, 4. To find the intercepts, or the y-intercept, you plug 0 into x. So 0 minus 4, that's negative 4. 0 minus 4 is negative 4, and negative 4 times negative 4 is positive 16, so 0, 16 is the y-intercept. And let's see, this has a degree 2, this has a degree 1. That's an odd function. Positive, so the right side goes up. Odd means the left side goes in the opposite direction. So it needs to go here and here. So it needs to go through negative 1, but bounce off of 4, because 4 has an even multiplicity. So up through 1, bounce off 4, and then head up. 20. Factor each of these guys. First off, degree 2, this is a degree 4 function. Positive, since it's positive, the right side goes up. Even degree means the left side's the same way. So when we factor this, we get a positive 3, negative 1. Those are the two numbers that multiply to negative 3 and add to 2. Factor this guy. Two numbers that multiply to negative 18 but add to negative 3 would be a negative 6 and a plus 3. So your x-intercepts are 1, 6, and negative 3 multiplicity 2. So 1, 6, and negative 3 mult 2. End behavior means they're going to be going up both directions. So we're going to bounce off negative 3 because it has an even multiplicity. So you bounce and go through the other 2 points, finish your graph. Forgot y-intercept. When you plug 0 into these guys, you get negative 3. Plug 0 into these guys, you get negative 18. So your y-intercept is 0, 54. Negative 3 times negative 18 is positive 54. That means this point is 0, 54. Uh, 21. I don't like negative being in front of x squared, so I'm going to switch stuff. I'm going to pull a negative out. That makes that a positive x squared, a positive 5x, negative 6. So when you pull out that negative, this factors into x plus 6, x minus 1. This factors into x plus 4, x minus 1. So our intercepts are negative 6, positive 1, multiplicity 2, and negative 4. Negative 6, negative 4, and 1 multiplicity 2. If you plug 0 into the original equation, we get a positive 6, negative 4. 6 times negative 4, our y-intercept is 0, negative 24. Okay. And it's negative, so the right side goes down. This has degree 2, degree 2. That means overall this function's degree 4. So the left side has to go down 2 because it's an even degree. It goes through negative 6, through negative 4, through the intercept, bounces off positive 1, and keeps going down. Write an equation for the graph. We know f of x equals a times, let's use the intercepts. That would be an x plus 3. Just a regular x because it goes through at 0. If you insist, you could put x plus 0. X minus 4. Okay. Now the right side's positive, so that means it should be a positive function. So it's f of x equals a times x. X plus 0 is just x. X plus 3. X minus 4. If you want, you can put in a positive number for a if that helps you. You can put in a 2, a 3, a 4. It doesn't matter because we don't know. We don't know what point that is or what point that is. We can't tell. However, if it says write the equation, we got to be exact. So you get f of x equals a, crosses at positive 1, so x plus 1. It crosses at negative 1, but it bounces, so you put x minus 1 squared. And then it goes through 2, x minus 2. Okay. So where this point comes in handy is we are going to plug this point into x, plug 3 into y, and solve for a. So 3 equals a times 0 plus 1, 0 minus 1 squared, 0 minus 2. Zero plus 1 is 1. 0 minus 1 squared is negative 1 squared. 0 minus 2 is negative 2. So 3 equals 1 times negative 1 squared is 1 times negative 2. That's negative 2 times a. Divide both sides by negative 2. And we get a is negative 3/2. So the official equation for this function is f of x equals negative 3/2 x plus 1, x minus 1 squared, x minus 2. Okay, these four problems are pretty much the same. So we got f of x equals, we got 0 molt 3, so that's, don't forget the a by the way, that's x cubed, 5 halves. So that means you would do 2x minus 5. And then 3 molt 2, x minus 3 multiplicity 2. Oh my goodness, I skipped all that. Let me show it again. A goes in front always. 0 molt 3, so x to the third. For the halves function, I know it's got to be a minus because that's a positive root. And the top number goes on the right, the bottom number goes in front of x because you had to divide 2 by 2 to get your 5. And then x minus 3 squared because it's 3 molt 2. So f of 1 is 36, so 36 goes in here. That's a times 1 to the third times 2 times 1 minus 5 and 1 minus 3. So therefore 36 equals a times 1. 2 minus 5 is negative 3. 1 minus 3 is negative 2. So 36 equals positive 6a. Divide both sides by 6. Therefore, your official equation is f of x equals 6, x cubed, 2x minus 5, x minus 3 squared. Fourth degree polynomial function with zeros. By the way, the way that helps is that's a third degree, 1 degree, 2 degree, 3 plus 1 plus 2 is 6. That's how you can double check. Sorry. Third degree, 1 degree, second degree, 3 plus 1 plus 2 is 6. That's how you can double check. 25. F of x equals 2 molt 3, so that would be an x minus 2 to the third power, negative 3/4. So that means you're going to have a 4x plus 3. Bottom number goes in front of x, opposite sign, that number goes last. And I forgot the a again, bad Mr. B. So 48 is the y-intercept. That means 0, 48. Your x value, y-intercept is 0, 48. The y-intercept is the y value when x is 0. So I'm going to plug 0 into x, 48 into y. So 48 equals a times 0 minus 2 cubed times 4 times 0 plus 3. So 48 equals a times negative 8, because negative 2 to the third power is negative 8, and that's times 3. So 48 equals negative 24 times a. Divide both sides by negative 24. A equals negative 2. So your final equation is f of x equals negative 2, x minus 2 cubed, 4x plus 3. Cubic function. F of x equals a, negative 4 molt 2. So x plus 4 multiplicity 2. And then 3, so x minus 3. P of 1 equals negative 20. That means your x value is 1, your y value is negative 20. Negative 20 equals a times 1 plus 4 squared times 1 minus 3. So negative 20 equals a. 5 squared is 25. So that's negative 50 times a. Divide both sides by negative 50, and you get, when you reduce, a equals positive 2/5. Therefore, your final answer is f of x equals 2/5 x plus 4 squared x minus 3. 27, write two different equations. Different ones? Come on, man. That has two distinct zeros, negative 1 and 2. So it says two functions, and it says it's a cubic polynomial. Cubic polynomial means it has to have a degree of 3. However, they only gave us two distinct zeros, negative 1 and 2. That means one of them has to have multiplicity 2. So we got f of x equals a. The zeros were negative 1, so x plus 1 and positive 2. And it says I have two different functions that I have to solve for. On the first one, I'm going to make the negative 1 have multiplicity 2. On the second function, the negative 2 has multiplicity 2. If I didn't give them multiplicity, they wouldn't be a cubic function. They'd be a quadratic. So x is 1, y is negative 4. Negative 4 equals a times negative 1 plus 1 squared times negative 1 minus 2. So negative 4 equals, that's 0. It should be a positive 1. My badness. So 1 plus 1 is 2. 2 squared is 4. And 4 times negative 1 is negative 4, so negative 4a. And divide both sides by negative 4 to get a equals 1. So one of my functions is just f of x equals x plus 1 squared x minus 2. For the next guy, again, negative 4 goes in the y, 1 goes in the x. 1 plus 1 is 2. 1 minus 1 is negative 1, but negative 1 squared is positive 1. So that's a times 2. Divide both sides by 2, and a equals negative 2. So you get f of x equals negative 2, x plus 1 squared, x minus 2. Those are our two equations. True or false? Not for this one. Is it possible for it is possible for a cubic polynomial function with real coefficients to have all imaginary roots? That one is false. The reason being, an imaginary root means it does not cross the x-axis, and because the polynomial function's an odd one looks like this, they have to cross the x-intercept at some point. B, it is possible for a fourth degree polynomial function with real coefficients to have all imaginary roots. This is true. The reason being, if you had a graph that looked like this graph never touches the x-axis, so that means all the roots are imaginary. For C, if r is a root of the polynomial function, then x minus r is a factor of that. That is true. If it's a 0, that means you should be able to plug it into this function, whatever the function is, and get 0. A polynomial function of degree n has n roots, zeros. That is true. So if it's a 4th degree function, it'll have 4 roots. If it's a 6th degree function, it'll have 6 roots. 10th degree function will have 10th roots. But a polynomial function of degree n has n x-intercepts. That is false. I'll give you an example. Looking back to one of the ones that we did earlier. Let's go. Number 14. Number 14 was a 4th degree function, and it had 4 roots. 1, 2, 3, 4. However, it only had 2 x-intercepts because those guys were imaginary. Okay, 29, more factoring, find all roots for each. I should probably use paper for this, just in case. So x to the 4th plus x squared minus 20. How long is this video? 50 minutes. X to the 4, find all zeros. So this factors into x squared plus 5, x squared minus 4. And this one can't factor anymore, but this one can into x plus 2, x minus 2. So therefore, x squared plus 5 equals 0. And that's subtract 5 from both sides. X squared equals negative 5. And if you square root both sides, you get x equals plus or minus I root 5. And the other intercepts from here are just negative 2 and positive 2. So those are all the roots. Your roots are I root 5, negative I root 5, negative 2, and 2. However, since these two are imaginary, that means that there are only 2 x-intercepts, and that would be negative 2 and positive 2. For number 30, number 30 says x cubed plus 4x squared minus 9x minus 36. So if I pull x squared out of the first group, I get x squared times x plus 4. If I pull out a negative 9 out of this group, negative 9x divided by negative 9 is x, negative 36 divided by negative 9 is positive 4. They both share x plus 4 in common, so I write that first. If I take it away from each of them, I'm left with x squared minus 9. But since that's a difference of 2 squares, I get x plus 3, x minus 3. So my roots are negative 4, negative 3, positive 3, and there are 3 x-intercepts. Okay, this is our main function. This says move everything left 5 spaces. I'm going to take the completed one here. Okay, so that's the original one. This would be your answer here because you want to move the entire graph left 5 spaces. So instead of 0, 0, it goes down over here to negative 5, 0. Instead of 1, negative 4, it's negative 4, negative 4. You just move it left 5 spaces. If it's inside the parentheses, that means it's either left or right, and it's opposite. So it's left 5. This one's inside the parentheses, which means right 2. So you move the entire function right 2 spaces. So this dot, instead of being here, moved over here. Instead of this dot being right here, it moved right 2. Since this is outside the parentheses, it's up 4. Outside the parentheses, it's down 8. It goes a little bit off your graph, so just kind of adjust for it. This says negative f of x minus 4, so you have to reflect it over the x-axis first. So this point up here does not reflect. Trying to get them side by side. So this point right here does not reflect. So it just stays right here. And then you follow the minus 4 description. So you go down 1, 2, 3, 4. This point here reflects up and over. But then it says shift it down 1, 2, 3, 4. This part does not reflect because it's already on the axis. But then you go down 1, 2, 3, 4. This point goes all the way over. So instead of 4, 8, it's 4, negative 8. And then it goes down 1, 2, 3, 4 spaces. And since this is on the intercept, it does not reflect, and it just goes down 4 spaces. Okay. And because this is a negative, it's a reflection over the x-axis, the end behavior is going to be different. So instead of it being positive on the left side, it's going to be negative on the left side. Instead of being negative on the right, it's positive on the right side. Okay. So same thing, flip it over and then move up spaces, up 8 spaces. This one has 2. It's a left 1, down 4. So you move everything left 1, down 4. Same thing, right 3, up 5. And that's it. I'll be here Monday morning around 7:15 if you have any questions. Good luck. I'm going to go home and take a nap.